Leaving Cert Higher Level 2018, question 6 in paper 1. You were given these two functions on a graph, and you were asked find the points of intersection of the graphs of the two functions. So we just let one equal the other. X is equal to x cubed. Divide across by x to get 1 is equal to x squared. So x is equal to plus or minus 1. So you can see here, this point down here on the left is going to be minus 1, because of x. This is the graph of y equals x, so whatever the x is, the y is going to be the same. This point up here is 1, 1. And don't forget about the third point. You can see it's here. It's at the origin, 0, 0. So the 3 points of intersection are 0, 0, minus 1, and 1, 1. Part B asks for the total area enclosed by the two curves. Well, they're symmetrical, so let's just look at one of them and we'll double our answer. And we know the total area is an integration type question, and between our two values of 0 and 1 here, so 1 on top, 0 on the bottom, and it's the top one always minus the bottom one, so it's going to be x minus x cubed. So we need to integrate x minus x cubed and fill in our values of 1 and 0. So if we integrate x minus x cubed, we're going to get x squared over 2 minus x to the power of 4 over 4, and that's between 1 and 0. Well, the 0 value here is not necessary. We're going to get 0 for it, so we're going to get 1 over 2 minus 1 over 4, which is equal to 1 over 4, and we need to multiply that by 2 to get 1 over 2. We should probably write units squared after it. Units squared. So that's the total area enclosed by the two curves. Part C of this question, using symmetry or otherwise, draw the graph of k to the power minus 1, the inverse function of k. Which one was k? X cubed. So we know, well, we have to write it as y is equal to x cubed. What we do is we simplify down to get x is equal to, and then we replace y with x to get our inverse function. So in this case, we would have y to the power of a third is equal to x. So the function that we need to graph, we replace y with x, is x to the power of a third. So let's look at the most obvious 3 points on this graph. If y now is equal to x to the power of a third, the point 0, 0 is definitely on that graph, and 1 to the power of anything is itself as minus 1 to the power of a third will be minus 1. If we get two more values within, let's have a look at the graph. We have our points of intersection here, here, they're going to be the same 3. So if we could say, well, let's approximate this to be 0.5 and get a value, it should be up here somewhere. And if we get a value for minus 0.5, we'll see that it's below the line here. So this curve, what it looks like is, it looks like symmetry. Now they told you it's symmetrical, so it looks like this. Let's just show that with getting these 2 points when x is a half and x is minus 0.5. So when x is minus 0.5, if you type that into your calculator, you're going to get approximately minus 0.8. And when x is equal to plus 0.5, you also get 0.8, but on a positive level. So let's just jump back up to the graph. 0.5. Well, that's the point 0.5, 0.5, because y is equal to x or x is equal to y. So 0.8 is up here approximately. And when x is equal to minus 0.5, this is the point minus 0.5 minus 0.5. So this is the point minus 0.5 minus 0.8. So if you couldn't see the symmetry of it, you could have maybe possibly gotten 2 more values here and here, here and here, and figured out how to draw the graph that way. So inverse functions and functions with question 5 in 2018.